today planning to solve GATE statistics previous year questions. That will also be helpful for the CSIR-NET people, even for the mathematics background people. So because because in CSIR-NET the question comes have the same syllabus as the GATE statistics syllabus.
Mhm.
So we can plan to
Yeah,
solve that, or if you can suggest what do you want.
yeah. Many of our members also prepares for GATE too. So certainly that will help. That will be helpful.
Yes, sir. So even the today the problem session we will conduct, that will help for the JAM statistics aspirant, GATE statistics aspirant, CSIR-NET mathematical statistics, sorry, mathematical sciences aspirants, है ना? Even it is people is from mathematics background or statistics background or from operation research or any background who are preparing for CSIR-NET mathematical sciences. So the mathematical sciences has unit 4, which is a statistics portion, and that covers all the topics that are in the GATE statistics actually. So yeah, we can start in 2 minutes till the people joins, right?
Yeah, we will start at 8 p.m. Let the others join by that time.
Yes sir, yes. So 1 मिनट का ब्रेक लेते हैं, ठीक है? यस सर.
Okay. Good evening, Dharmendra. Yeah. Yeah. Hello, Saik. Good evening.
स्कूल इतने ग्रुप्स हैं ना, हाँ सब में, पब्लिक वाले में भी, जिसमें एडवर्टाइजमेंट करते हैं ना, सब में डाल दीजिए. पानी दे दीजिए.
Yeah, good evening, everyone. Am I audible?
Yes, sir, you are audible.
Okay, thank you. So let me introduce Mr. Santosh. Yeah, 1 minute. Dear friends, Maths Aspirants is a collective of mathematics students, research scholars across India, initiated by myself in 2017, and we used to organize online problem solving sessions and online test series to help the students who prepare for different national level competitive examinations. As a part of that series, today we blessed to have Mr. Santosh Kumar Chaudhary. He is currently an assistant professor of statistics at Birla Institute of Technology, Misra, Ranchi, Jharkhand. Mr. Santosh did PhD in mathematical statistics from IIT Kharagpur and MSc statistics from IIT Bombay and MSc mathematics from IIT Delhi. And also he did his BSc from Delhi University. And Mr. Santosh qualified IIT JAM with All India rank 17, GATE with All India rank 3, and NET, CSIR-NET JRF with All India rank 50. So I'm sure that today we have the most right person to discuss problems related with probability and statistics with you. And I'm very happy that Mr. Santosh already had handled one session in our platform, and this is the second session. I'm sure that today's session will be really beneficial to all of you who are seriously preparing for the forthcoming competitive examinations. So I would like to express sincere thanks and gratitude to Mr. Santosh for accepting our invitation and joining with us. I welcome everyone to this program. Welcome, Santosh.
Yeah, thank you so much, sir. And sir is doing very nice work for the people who want quality education and free of course. Sir is helping. So I also try to help sir in that initiative. So because this is a very novel work and he's doing. I know actually my junior in IIT Kharagpur, Gaurav, told me once. I think 1 year ago that there is a professor in Kerala who is doing something. So I was not knowing. Then I searched somewhere. Then I found sir on LinkedIn. Then I thought, okay, let's. So I text sir that I can help you if you need. So then last time I took one session, and that in that I solved CSIR-NET PYQ of a statistics portion. So today this time I will be solving random variable questions of GATE statistic, and this will also help CSIR-NET aspirants. So unit 4 of CSIR-NET syllabus has a statistics portion, and there also operation research, optimization, all that. So in a statistics portion, this portion will help because the statistics syllabus and this session, today's session, will help IIT JAM MS aspirants, GATE statistics aspirant, CSIR-NET mathematical science aspirant, or anyone who want to learn basic probability, basic random variable topic. So it will help those. Even there are people who want to learn that. So this session will be helpful to those people. So okay, let's start. So in this just I have collected few questions from GATE statistics, and similar questions are asked in CSIR-NET mathematical science also unit 4. So we can discuss this. So these are some questions that you can see. So I think it has around so I have 1.5 hours, so I will try to discuss as much as we can. So this will have, I think, 20-30 questions, maybe 16 questions only. Okay. So so let's start with the first question. So question is actually k is a number 1 2 3 up to 10, है ना? The probability density function, so PDF. So I will also briefly explain theory behind the question. So this probability density function of random variable xk. So xk is a random variable, k is index, and that can take value 1 to 10. So this is a PDF. So we may import this. So now you can see here. So what is a PDF? First question is, what is definition of PDF? So for the people who don't know anything about probability or statistics, so I will first explain what is this, and then we'll solve the question, है ना? So definition is, what is PDF? So if I write the definition, so full name is probability density function, and in short we say PDF, PDF. So definition of PDF is actually so definition of PDF, it is a function. So let's say a function fx is called, so this called PDF of a random variable x if and only if there are two conditions. Any function that satisfy these two conditions will be PDF. The first condition is fx should be non-negative for all x belongs to R, and the second condition is integral over minus infinity to plus infinity should be 1. So this is the condition. Any function that satisfy these two conditions is PDF of some random variable x. Okay, so so we can see in that question we have one random variable xk, means we have 10 random variable actually, x1 x2 x10, because k can take value 1 to 10 anything, right? So I think you can pin my screen so that will be visible, I think. Anji Dharmenji, I think, is it fine? See, so so xk, so
Not
k can
visible
take
for
value
me.
this.
For others,
Yes, yes, Dharmenji, is it fine? विजिबल है ना आपको? ठीक है, कंटिन्यू करते हैं. सो है ना, सो लाइक इफ आई write this is something like, you may write it lambda e की power or 1 by lambda e की power x by lambda x more than 0. So you may compare this PDF as this. So this is called PDF of exponential random variable. There are some special PDFs we have named, like exponential distribution, gamma distribution, beta, normal. Okay, so this PDF is called PDF of exponential random variable with rate 1 by lambda, mean lambda. So this is the exponential. This is very helpful in Markov chain. Markov chain is part of CSIR-NET mathematical science syllabus. So exponential distribution is helpful in Markov chain also. So now you can compare like this. So here in place of lambda we have k actually. So if I complete this, so you can say, so what we say here, x has a distribution exponential rate 1 by lambda. So I will write rate 1 by lambda and mean will be lambda. So if you find ex, so what is the definition of ex? So since they have asked you to find ex, so what is expectation actually? So the definition, if I continue further, so this is a definition of PDF, and if I define expectations, and in short we write ex. This is a function, again it is a function. So expectation, okay, let's write full singular form, expectation. So let x be a random variable, then ex is called expectation of x. So we denote ex as so we denote ex as expectation of random variable, and it is defined as e of x is equal to, now depends on whether it is discrete random variable or continuous random variable. So currently I'm writing for the continuous random variable. So what is discrete and what is continuous? So in the continuous random variable, support will be uncountable set and probability at each point will be 0. In the discrete, the support, what is support actually? Support is a range of random variable. So ex just I'm defining for the continuous one. So fx, this dx minus infinity to infinity, provided integral mod x into fx of x dx, this is finite number and this is finite. So the definition of expectation. Okay, so I wrote here two definitions, one is for the PDF, another is for the expectation, and both is for the continuous random variable. So PDF is this, any function that satisfy these two conditions. Expectation is this, under the condition that this integral should converge absolutely, right? So this integral must converge absolutely, then Ex is defined. Otherwise, Ex is not defined. Okay. Suppose this integral becomes infinity, then Ex is not defined. So under this condition that this integral should converge absolutely. So in this PDF, if you find Ex with this definition, so you will have rate is 1 by lambda. We say this is rate. So mean will be lambda actually. So Ex will be lambda here. So using this fact, E of xk. So you can compare these two functions. Okay. So in place of lambda, we have k here. So here mean is lambda. So in the random variable xk, we will have mean as k, right? So we'll have mean as k because lambda is k. So in this question, expectation of the random variable whose PDF is this is actually k. And now what they are asking us? They are asking us to find expectation of summation kxk. So we can open this, right? So now using the property, so property is, if I write further property of expectation, so one property is this remark or theorem I can write. So the theorem is expectation of, let's say, a1 x1, a2 x2, and so on, an xn can be written as, this can be written as a1 time expectation of x1 plus a2 time expectation of x2 and so on, an time expectation of xn. And this can be proved easily using this definition. If you use this definition, this is very easy to prove. You find LHS using this definition, find RHS using this definition, and both will, or just linearity of integral. So now what is this? So we can just if you open this, it is like 1 into x1 plus 2 into x2 plus 3 into x3 and so on. So we can write summation outside, or I write this briefly. That is what I'm saying, ki expectation of summation ai xi, I from 1 to n, can be written as expectation of summation ai xi. So summation can be taken out, ai is a constant, so that can taken out of expectation, and now you have expectation of xi, I from 1 to n. Okay. So using this property of expectation of random variable, we can write this as summation is outside, k is outside, expectation of xk, and k from 1 to 10. So summation k time, what is expectation of xk? So we have seen here expectation of xk is k, so you replace it, so k. So now it is k into k from 1 to 10. So now we have k square, k from 1 to 10. If we expand this summation, so we have something like 1 square, 2 square, 3 square, up to 10 square. And we already know sum of square of natural numbers up to n terms. So we have this formula as n into n plus 1, 2n plus 1 by 6, right? N into n plus 1, 2n plus 1 by 6. So you can cancel it out. 3 7 ja, 3 2 ja, 3 5s are. So we have now 5 into 11 into 7. So it is, you just simplify it, huh? So you will multiply and this will be the answer. So this is the answer for the first question. So if anyone has any query regarding, so just like I'm focusing to the people who are for mathematics background, because for the people who are from a statistics background may find it easy, but the one who are from mathematics background may find it difficult. So just I'm here presenting it for the mathematics background people. So I'm explaining every terms. So PDF, then expectation, I define and then use this. Yes, anyone has any query, you can ask. Unmute and you can ask if you have any query. I think in the chat. Uh, okay, so you are saying AI should be independent of xi's. Okay, so AI is a scalars. Okay, so I think it don't have to do anything with AIs are scalars. So AIs are real numbers. Okay, just arbitrary numbers a1, a2, a3, a4, and so on. So they are some real numbers. Or obviously it will be independent of xi's. Any constant is independent of any random variable. So like constant random variable is called degenerate random variable, and degenerate random variable is independent of any random variable, even itself. So there is a single random variable which is independent of itself is degenerate random variable, which is constant random variable. So ai's are constant. So obviously it will be independent of xi that we are saying. So you are also right. Okay. So it is independent. Yeah. So ai's are independent always for any random variable. Okay. Yeah. So ai's will always be independent. So this was the theory behind that question, and this is the solution of this question. So I know sometimes this type of question also, it's not like in CSIR-NET all questions are difficult. Few questions are easy also, even in a statistics portion. So if you have basic understanding, you can solve it. Okay. So if you don't have any other query, we can proceed further to the next question. Okay. Yeah. So I defined PDF, expectation, property of expectation, and that lead to the solution of this question. Okay. So next question is second one. The second question is this one. So this was for the univariate random variable, single random variable. This is from bivariate random variable, hai na? Or you can say bivariate distribution. That was univariate distribution. You had just one random variable. Now you have two random variable. So this is called joint PDF. So okay, let's try this. So again, the word similar word is used, PDF of a random vector xy. So what I defined was PDF of a random variable. So RB here I mean random variable. Random vector, vector means more than one random variable taken together. So the same vector is also used in linear algebra. So this is the same vector. So okay. So what is definition of PDF of a random vector? The first I will define here what is the definition of joint PDF of a random vector, and then what we need, value of C. So this is basically on the definition of joint PDF of random variable xy or random vector xy. So let's define this term first. So this was the definition for the univariate random. If you have single random variable, any function fx will be called PDF, probability density function, if and only if it is non-negative, and single integration is equal to 1 over r. Now I will define the PDF of random vector. That will be required in this question. So that we need. So let's define this. So definition of probability density function of random vector x comma y. Okay. So x alone is a random variable, y alone is a random variable. So we have written as an ordered pair. So this is a two-dimensional random vector. Okay. So now what is the definition? So a function f of x comma y. So it is a two variable function. So a two variable function will be called this is joint. So we'll use joint PDF, hai na? Instead of writing just PDF, we'll use joint PDF because the function will represent PDF of both random variable together. So it is called joint PDF. So we may write it joint PDF. So it is joint PDF. So definition of joint PDF of random vector. So of two variable function, this is called joint probability density function of x comma y, if and only if. Again, you have similar two conditions like the last definition. So the first condition is fxy must be non-negative for all x comma y belongs to r square, and the second condition is double integration dx dy or dy dx, this must be equal to 1 over r square. So this is definition of joint PDF. This is just multivariate version of or bivariate version of this definition. So this was the univariate definition, and just we generalize it for the two random variable. So we extended it for the two random variable. So it is the bivariate extension of the simple PDF of single random variable. Okay. So only knowing this is enough to solve second question. If you know this, this is enough. Okay. So So if you know just definition of this, then it is enough to solve this question. You just need to find suitable C for which it becomes joint PDF. So definition says, है ना? So they have written just suffix xy is just representing the random variables. So this should be non-negative. So that implies C should be non-negative. The first thing, C must be non-negative. So one condition we got is C must be non-negative. And the second condition is double integration dx dy or dy dx, whatever you prefer. So this should be, this must be 1. So let us calculate this and then we'll put it equal to 1. Then we'll get the value of C. Now you see carefully. This function takes value C on this domain. And this function takes value 0 on otherwise. So means what? If I draw the graph of this, so you have x between 0 and y. So this graph is x is equal to y. So x is between 0 and y. So x is, this line is x is equal to 0. This line is x is equal to y. So x is between 0 and y, and y is less than 1. So let's say restrict it to 1. So this line is y is equal to 1. So the shaded region represent the domain at which joint PDF has value C, and otherwise it is 0. Check it. Okay, so x is between 0 and y. So x is equal to 0, x is equal to y. The x is between 0 and y is less than 1. So y is restricted by 1. Okay, so the triangle, shaded triangle, is the region where joint PDF will have value C, and on the otherwise outside the shaded region the PDF takes value 0. Okay, so PDF takes value 0. So what we have to do? We have to break this integral into two parts. One over this shaded region and otherwise. So if you break this integral, so okay, so this PDF will have value C over this shaded region, and this PDF will have value 0 otherwise. So outside this shaded region, because support, or you say definition, we have taken whole r square, integration over r square. This is the integration over r square. So we are breaking integration into two parts, one for the shaded region, for the otherwise. So this will become 0 otherwise. So there is no need of this term. Now you have C, and you have to write the limit over this support or this region. So if I write, so I need to take limit of x first. So you make a line parallel to x-axis. Some people face issue how to take the limit. So few of them have this doubt. So if you are writing dx first, so make a line parallel to x-axis. So see what is this region. This is x is 0. What is this? So you see the boundary. When you draw a line, you see the boundary. What are the boundary? So one boundary is x is equal to 0. Other boundary is x is equal to y. So limit will be x is equal to 0 to y. Now take the projection over y-axis. So you take the projection of this shaded region over y-axis. So what will be? So if you take the projection over y-axis, so it will be over this line. This is 0 to 1. So y is 0 to 1, and this term will become 0. So you ignore this. Now, and we have given, so we have given it is 1. By definition of joint PDF, that integral must be equal to 1, and this will give us value of C that we need. तो चलो सॉल्व कर लो. सो नाउ अच्छा एक काम करते हैं ना, सी को बाहर कर लो. तो सी को जब बाहर कर लोगे तो ये कुछ ऐसा हो गया, डी एक्स डी वाई. इंटीग्रेशन करने की जरूरत नहीं है ना, because this represent the area actually. So you can do one thing, you can just find the area. Okay, so if you just find area of this triangle, so what is area of this triangle? You may integrate, still you will get the same answer. Without integrating, you will also get the same answer. So so if you take C outside, this is 1 dx dy over this region, 0 to y and 0 to 1. So this represents area of the shaded region. So even if you integrate, you will get the similar answer, same answer, exactly same answer. But I'm not doing integration, just take the area of this triangle. So this is base length 1 because x is equal to y. So this is a right triangle having base length 1 and height is 1. So it will be C time half into base into height, area of this triangle equal to 1. So from here, c by 2 is 1, so c is equal to 2. So this is the answer for this question. Now if anyone has any doubt, you may ask. See, this is just based on definition of joint PDF, and that is, again, I'm saying these type of questions are also asked in CSIR-NET. Okay ji? So is it fine for everyone? So this was based on this definition, based on this definition. So what is the definition of joint PDF of random vector? So using this definition, you got this. Okay.
Sir,
Yeah.
don't know to, sir, want to able to understand from diagram how we are selecting limits, sir.
Okay.
In algebraically able to understand that 0 less than x less than y less than 1.
Yeah.
So by diagrammatic, I want to understand that limits, sir, how we are applying that.
Okay. So what you can do? So in the this is the reason. Okay, inequality represents reason. So what you do first? You first draw the lines or the curves which are at boundary. So what you can do? Suppose you don't know how to draw graph, how to select reason. So what we will do? You first draw the boundaries. Boundaries means everywhere you see inequality, you put it equality. So this reason is something like 0 less than x less than y less than 1, right? So you do one thing, x is equal to 0, x is equal to y is equal to 1. So you can make graph of these curves easily. So what I did, just I took equality instead of inequality. Then later we'll decide whether which side we have to go, because inequality represent the reason, equality represent the curve, points on the curve. So you can draw graph of x is equal to 0, x is equal to y, and y is equal to 1. So what we can do, x is equal to 0 means y axis. So x is equal to 0 means y axis. X is equal to y, this we know already. So this line is x is equal to y is equal to 1. Okay. Now you see, so here is x is 0, and here we had to select x more than 0. So now you know this line is x is equal to 0. So either you will go this side or you will go this side. Now you need to decide, you will go left side or you will go right side. So according to the inequality, so x is more than 0, so you have to go right side, because inequality is saying x is more than 0, so you have to go this side. So solution will be this side. Next, x is less than y. Now you need to decide, okay, this is a line, x is equal to y. Which side you will go, whether right or left? So one side will be x more than y, other side will be x less than y. Now you need to check, okay, which side we have to go, because we have the reason x less than y. So we have to select which reason is x less than y, this side or this side. This you need to select. So there is a concept of testing point. You randomly choose any point on the xy plane which is not on the line. So let's take, here I choose a point 1 comma 0 for example. So 1 comma 0 is a testing point that I'm testing whether it is which side. So what you'll do, here you have x less than y. So you put x is equal to 1, y is equal to 0. So just I'm checking whether this point uh, is in this region or not. So what you'll do, you put x is equal to 1, y is equal to 0. So x is 1, y is 0. 1 less than 0. False statement. So false statement means you are on wrong side. So means you cannot go this side. You have to go this side. You choose any testing point above this line, you will always get a true statement, because the true means you are on right side and false means you are on wrong side. Okay. So this, again you have y less than 1. So what you will do, this line is y is equal to 1. So above this y is more than 1, below this y is less than 1. So here you have to go y less than 1. So you have to go this side. Now you select the common reason. So it said this side, it said this side, it said this side. So only reason lies in all three is this one. Is it fine? See.
Yes, sir. Thank you, sir.
Yeah,
Thank you
thank
so
you.
much, sir.
So okay. So let's come to the third question. The third question is based on moment generating function. Okay. So I need to define, because I assume no one knows nothing. So I'm presenting like this. So moment generating function. So we have to first define what is the definition of moment generating function. So how to define moment generating function of a random variable x. So let's define first, then I will come to this question. So moment generating function is, in short, we say MGF, and full name is moment generating function. So definition is, so let x be a random variable. So moment generating function of x is defined as, so notation is mxt. So notation is mxt. So mgf is denoted as, I may write it, denoted as mxt and defined as, so this is a notation for the moment generating function of x, and variable will be t. T is a variable here, and definition is expectation of e raised to power tx, and the expectation we have already defined, right? This is the same expectation that we defined here, that we defined here. This is the same expectation. So this is the expectation. So if you further open it, so now the definition I have written for the continuous random variable. If you define the similar for the discrete, then integration will become summation, because discrete random variable has a range countable set, and over countable set you do summation. Continuous random variable has support uncountable set, and over uncountable set we do integration. Okay, so that's why. So further, this can be open in two ways. So like suppose x is continuous random variable. So x is a continuous random variable, then mgf will be defined like integration e raised to power tx. Okay, so t is the variable. So what will be domain of mgf? So domain of mgf will always contain origin 0. So domain must contain origin. So like t will belong to some interval containing origin. So it may be like 0 minus epsilon to 0 plus epsilon. Epsilon is an arbitrary real number, maybe 0, sorry, maybe 0.1 or maybe 100, maybe 1000, maybe millions, no problem. So like so epsilon is a arbitrary real number, arbitrary positive real number. So okay, so domain of this will be 0 minus epsilon to 0 plus epsilon, means domain of mgf must contain origin. So even this function is continuous and differentiable over 0. So now definition will be e of tx into pdf of x dx. So you remember when we were finding ex, so it was x time pdf. Now we are finding expectation of e raised to power tx. So with we replaced x by e raised to power tx as a definition. Okay, so this will be, and whatever support of x is for the continuous. If x is a discrete random variable, second, suppose if x is a discrete random variable, so if x is discrete random variable, then this mxt will be summation e raised to power tx. So this was pdf that we defined. This is the pmf, probability mass function. So discrete random variable has pmf and continuous random variable has pdf. Okay, 1 minute. So whatever value of x will be countable set, but any possible value it may contain. So this is the probability at a point. So now so what is definition of pmf? I defined pdf there. So let's define pmf, probability mass function. So probability mass function, and in short we say pmf. So like pdf, pmf is also a function. Okay, so a function, let's say I say small px, which will actually represent this probability at a point. PDF is not a probability at a point. PDF is a function under which you will get the PDF. Here it is a probability over a point. So this is PMF of X if and only if. Again, you have two conditions like the PDF, similar way. So you will have Px as more than equal to 0 and summation Px must be 1, whatever the value of X taken. So summation due to discrete random variable, integration due to continuous. Continuous means uncountable set. So so this is the definition of PMF, probability mass function. So this I used is the PMF, and summation we are using because of discrete random variable. Discrete random variable has a range, countable set, at most countable. So obviously countable. Okay, so let's come to the questions. Now, if you open this, okay, let me write one theorem and that will help us. So I write a table. Suppose X is a random variable whose range is something like x1, x2, x3 and up to xn. So x1, x2, xn are real numbers, and this is the probability of capital X at a small x. So it is p1, it is p2, it is p3 and it is a pn. This is also a PMF actually, probability at a point. So where what I'm writing, so this is a PMF of random variable X whose range is x1, x2, xn. So here pi represents probability of X is equal to small xi, and the range of X is x1, x2, x3, x4. These are the values of X, capital X. A small x are random variable. Sorry, capital X is a random variable, a small x are real numbers, which is in the support of this. Now, this is a PMF of random variable X, probability at a point, or you simply write this. So again, like this will be non-negative, and summation of pi I from 1 to n must be 1. Okay, definition of PMF, non-negative function whose sum is 1, because we have restricted here x1, x2, x3, xn are the range of capital X. What will be MGF? So according to definition, if you find the MGF, it is summation e raised to power tx into probability of X. So let's write xi. Here I write xi, I from 1 to n. If you further simplify it, just I'm using definition of MGF that we have written here. So this definition I'm using, because for the discrete random variable I'm finding MGF. So MGF for the discrete random variable. So you can write it summation e raised to power t into xi into pi, I from 1 to n. Okay. So for this PDF, this is the MGF. For this MGF, this is the PDF. So there is a result that says every distribution, whether it may be PMF or PDF. So every PDF has unique MGF. Every MGF determine unique PDF or PMF. So what I want to say, if MGF exists, corresponding to one distribution, you will have unique MGF if it exists. And if you have a MGF, it will map to a single distribution, maybe discrete or continuous, not both. So every distribution has unique MGF if it exists, and every MGF correspond to unique distribution. So what I want to say here, this is the PMF, so this is the MGF, and this is the MGF, this is the PMF. So this is if and only if condition. So what I'm saying, this is if and only if condition. If and only if. So this is a PMF of random variable. This will be the MGF. This is the MGF. This will be the PMF. We can open it. If you open summation, it will be something like, and not for the discrete only, for the continuous also. It is unique. So that is MXT is e raised to power t into x1. Let's write p1. P2 e raised to power tx2, and so on. Pn e raised to power txn. Okay, so this is the theorem we will be using to solve that question actually. See, so if you have given this MGF, you can write this PMF, probability mass function. Probability mass function is for the discrete random variable. Okay, so it's fine. So now come to the question. So what I defined moment generating function, and then we have written one theorem based on this MGF of discrete random variable, and this is the definition of PMF. So continuous random variable has PDF, probability density function. Discrete random variable has PMF. So continuous will not have PMF, discrete will not have PDF. Okay, so continuous will have PDF, discrete will have PMF. So there are on a broad sense there are two type of random variable, or if you see very closely or you say strictly, then there are three type of random variable: discrete, continuous, and neither. So there are few random variable which is neither discrete nor continuous. So that I usually say mixed random variable. That book don't use the word, but I say mixed random variable. So okay, so come to that question. Now see the question. So you have given MGF. So now can you tell me the PMF? See carefully. This is something like, this MGF is something like P1 e ki power tx1, P2 e ki power tx2. How many terms are there? 1, 2, 3, 4. So there are 4 values in the domain of x, in the range of x or support of PDF. So P1 e ki power tx1, P2 e ki power tx2, P3 e raised to power tx3, and P4 e raised to power tx4. So this is the MGF that is given to you. So what I said, every MGF determine unique PMF if it is for discrete, and every PMF has unique MGF. So for this MGF, we have this PMF. For this PMF, we have this MGF. So for this MGF, we will have PMF like X, PX. So X1, X2, X3, X4, P1, P2, P3, P4. So can we make this? Yes. So you can see, just compare. So PMF of X, this is if and only if condition. This MGF will have this PMF, this PMF will have this MGF. So now what are the powers? You compare. So 1 by 6 e raised to power 0t. That's why e is not there. So X has value 0, 1, 2, 3. Compare in the coefficient of t in e raised to power tx. And this is a probability. So this probability is 1 by 6. This probability is 1 by 3, 1 by 3, 1 by 6. You can easily verify this is the PMF. Means sum of all will give you 1, and each are non-negative. So each of them is non-negative. Okay, so this is the PMF of X. Now, what they are asking, what is the probability X less than or equal to 2? So means they are asking you the probability corresponding to all those value of X which is less than or equal to 2. So means they are asking us to find probability corresponding to 2, 1, and what are the value? 0, 1, 2, 3. So see those values which satisfy this condition. So they are 0, 1, 2. This will not be there in that case. So you just need to add 2, 1, and 0. You add these probabilities. So what are the probabilities? So we have now probability at 2 is 1 by 3, 1 by 3, and 1 by 6. So add it. 2 plus 2 plus 1. Is it 5 by 6? So 5 by 6 is the answer to this question. So D is the option. Now if anyone has any query, please ask. Okay, so this was question based on MGF, moment generating function. When moment generating function is given, how to find probability using MGF. So this result was used. So this theorem is used to solve this question. Okay, so I will go to the next question if no one has doubt. Yeah, Praveen, you're right. Okay, so let's go to the fourth question. Okay, So the fourth question is, so let x be a non-constant positive random variable. X be a non-constant positive random variable. So positive random variable means x values of x will be positive number. It is a non-constant, and such that expectation of x is given as 9. So they are asking which of the following statement is true. So again, this question is based on expectations, and this is a probability. So what can you say about expectation of 1 by x plus 1 and the probability x more than equal to 10, है ना? So expectation 1 by x plus 1 and probability x more than equal to 10. So anyone has any idea how to solve this? So there are many way. Okay, so one of the way is theorems again. Theorems are made for the solving question easily, whether otherwise you have to prove everything if you don't use theorem. So this gives me the idea of two inequalities. One is, so this giving me the hint of using Markov inequality, not Markov. I think this is for the Jensen's inequality. Okay, and this is for the Markov inequality. So this will be solved based on Markov inequality, this part, and this part will be based on Jensen's inequality. So question is, what are the statements? So let's write a statement. So I will write first Markov inequality. So it says, let x be a non-negative random variable and k is a positive real number. Let's say k is any real number. Okay, so simply let's write then expectation of, not expectation, the probability of x more than equal to some number n, or you may write some number k, is less than equal to ex upon k. Okay, so x probability of x more than equal to k, this is a theorem that is named as Markov inequality. So x more than equal to k is less than equal to ex upon k for some k is more than 0, because x is non-negative random variable. Okay, so now so apply this. The next theorem I was talking about is Jensen's inequality. So Jensen's inequality, it is again a theorem, Jensen's inequality. So what is the statement of Jensen's inequality? So let G be a convex function, at least on the range of random variable x. So G be a convex function and x be a random variable, and x be a random variable. Then, so this theorem talks about expectation. Expectation of gx is more than equal to g of expectation of x. So, so what is the condition when you can interchange expectation on function g? So these two theorems we will be using. And what is convex function? So I hope mathematics background people know well. So if it is differentiable function, then derivative is, I think, if and only if condition is there. If function is g is twice differentiable and g is convex, if and only if g double dash x is positive. If it is differentiable, double differentiable, then okay. So what is convex functions? Okay, let's define. So what is convex function? A function g is convex if and only if g of lambda 1 x1, or you say lambda x1 plus 1 minus lambda x2. So this is a line segment joining 2 points x1 and x2 on the x-axis. So this is x1 point, suppose this is x2 point. So this represents the line segment joining x1, x2. And applying g means talking about image of the function. So this is image of this function over this. So this is the left side. And this is the line. So this height is, what is coordinate of this point? X1 comma gx1, and this point is x2 comma gx2. Okay, so x1 comma gx1, x2 comma gx2. So this will be less than equal to, so image of line segment this is less than equal to line segment joining gx1 gx2 for all x1 comma x2 belongs to domain of function g. So D is a set that is domain of function g. So this is a definition of convex function. And if I write something wrong, you may correct me. So see, so this is a definition. So image should be less than equal to the line segment joining this. Okay. So theorem comes that help us to solve. So twice differentiable function gx is convex function if and only if g double dash x is positive, at least non-negative, right? For all x belongs to domain of function g. Okay, so I have written 4 things here. Markov inequality, Jensen's inequality, definition of convex function, and theorem of convex function. Okay. If anyone has a query in this, you can ask. So Markov inequality, Jensen's inequality, definition of convex function, theorem on convex function. Now, so this is enough to solve the next question. If you use this condition, you can easily solve next question. Now you can try. So the k is here 10. Okay. So the k here you are seeing is 10 here. Okay. So if I use here probability x more than equal to 10, so it will be less than equal to ex upon 10. And in the question, we already have given ex. So it is 9 upon 10, and which is 0.90, right? Correct? So this is more than, right? So this cannot be true. So CD option out. So we have discarded CD option. Now A and B. Okay. Now you have to consider gx as 1 upon 1 plus x. So x is a positive random variable. It was already written x is a positive random variable, means x is more than 0. It is already written x, the values of x will be positive only. So domain here is obviously positive. It is given in the question. So we just consider gx function on the range of or support of random variable x, or with the values of x. So this is differentiable function on this. Yes, because it will not be differentiable at -1, but -1 is not in the domain. So you find g dash x, it is -1 1 plus x whole square. You find g double dash x, I think it is 2 upon 1 plus x whole cube, which is more than 0 for all x more than 0, which was values of x. So G double dash X is positive. Now you can write non-negative also, no problem. So this theorem says if double derivative is non-negative on the domain of the function, then this function is convex on its domain. So now we got that Gx is a convex function for x more than 0. Okay. So we can apply Jensen's inequality. So we can simply apply Jensen's inequality. So what is Jensen's inequality? See here. Just apply Jensen's inequality. It is saying if g is the convex function, then expectation of gx will be more than equal to g of expectation x. So expectation of gx will be more than equal to g of expectation x. G of expectation x. So g of gx is this. So 1 upon 1 plus ex. Is it fine? See, and ex we have given as 9, so that we can put here. So this value will be 1 upon 1 plus 9, 10, which is 0.10. Okay. So now e of 1 by 1 plus x is more than equal to, I think it's strictly more than we can write here because option is asking this. So so ye to out ho jayega. So this will be correct here. Okay, because this is going to be positive. So when x is more than 0, gx is strictly more than 0. And again there is a condition, like if I say here x is, this will be the condition. Okay, so this is fine, this will discard the option, so that will be 0.10. So a is correct option among given options, right? So if anyone has doubt, you tell. So this question was based on yeah.
So what to do if the function is not convex?
Okay, so if function is not convex, then we will try to find using definition. So we may find e of this and something. So the thing is, you have to understand the approach of the question, so what they are expecting you to apply. So since I understood from the question only, so here the intention of the person who made this question was to apply Jensen's and Markov. But even it is not convex, you may try to maybe concave, then minus se multiply kar doge, then it will become convex, something or something will be there. So means if it is not convex, then some other way will also be there. So if some questions comes, then we can find that also. Okay, so
Okay,
here
thank
is
you,
the
sir.
way only Jensen's inequality they asked, maybe some other option also.
Okay, sir. Thank you.
Yeah. So next question is this one. Okay, this is interesting. So they have used expectation CDF. There is a new word now, distribution function. So distribution function is brief name of cumulative distribution function. So cumulative distribution function and distribution function are same thing. So
Sir,
yeah, tell. Do you want to
and
ask?
the previous question, if the function is not convex, then can we say that the result in the opposite direction, like expectation of that function will be less than or equal to
No.
that
If it is
function of
concave,
expectation?
so what you are saying for the concave function, so opposite inequality will come for the concave function.
Yeah.
Yeah. So concave is just opposite of convex. So like if you write concave in the definition, so if like gx is concave function minus gx is convex and vice versa. So if it is not convex, then you cannot write key inequality will be reversed. You can write if you know it is concave function, then you can write. Otherwise, maybe function neither concave nor convex, maybe. So then you cannot write.
Okay.
Yeah.
Okay. Sir, also, like in this kind of questions, can we use any familiar distributions satisfying these conditions and check
Exactly.
with that?
So like one of you also asked, what if? So okay, let's do this with other way. So I will not use Jensen's inequality. I will not use Markov inequality. Then still we can solve, like you said. So okay, let's try. So without using Jensen's and Markov, it will also be solved. So even if it is not convex, like you said, or you are not able to check, then we can solve this question without using Jensen's or without using Markov. Okay, let's try. So then you have a discard option. Okay, so they said x be a non constant positive random variable and ex is a 9. So what we can do, we will take suitable example as per given information, then we'll discard the other options. That can be done. So we can try. So just I'm trying. I don't know whether it will happen or not, but okay. So can you suggest some distribution whose support is positive and expectation is 9? Suggest any distribution.
Yeah, sir, a uniform distribution
Yes, correct.
of
Uniform 0, 18.
0 to
Yeah, it
18.
will work. So support is positive 0 to 18 and expectation is 9. A plus b by 2. Fine. So let's calculate this thing and this thing. So now we'll find. So just I'm taking example. So example will not choose correct option. Example will discard the false option. Then remaining will be correct actually. So okay. So if you find, so let's find probability x more than equal to 10. So this is something like 10 to 18, and PDF of uniform is, so here the PDF will be 1 upon 18, right? Uniform AB has PDF. So for the information of people who don't know anything, let's define uniform distribution. So X has a distribution uniform over AB if and only if probability density function of X is 1 upon B minus A for X between AB and 0 otherwise. Okay, so we say random variable X has distribution uniform over interval AB if and only PDF is this. And further, like I have already written definition of expectation. So if you find EX, so you will just using definition, you can just find X into PDF of X dx, or you will just integrate it 1 upon B minus A integration A to B. So you will have A plus B upon 2. You can check. Okay, so you will have A plus B upon 2. So that I will be using here. Okay. So what example we considered? We considered uniform 0 because this is called range of random variable or support of random variable here. So we have considered uniform 0, 18. So PDF will be 1 upon 18 minus 0. So it is 1 by 18. So 1 by 18 dx. Okay. So let me write one more theorem. So let X be a continuous random variable, then probability X is between A and B, or anything you can take. X between anything like any number you can take. AB you can consider. This is not the same AB, that's why I'm changing notation. C to D. So this will be C to D integration of PDF. It's simple. If you want to find the what is the probability of X will belong to interval CD, then it will be integration C to D fx dx. So I'm using this condition to find this probability. So means X is more than 18, more than 10, less than 18. So this will be 8 upon 18, right? So it is 4 upon 9. And what is the decimal form of this? 0.4, right? Something
Yes, sir.
0.4, then 40, 0.4 approx.
0.44.
44, yeah. So what we got? 0.44. This we got 0.44. This we got 0.44. This we got 0.44. So we didn't use Markov inequality here. So 0.44 less than 0.9. Yes. So this may be correct. Yes, may be correct. 0.44 more than 0.9. No. So this two out. Okay. So this two option is out because it is saying 0.44 is more than 0.9. This is false. So okay, out. Now let's find this. So if you find expectation of this, so the definition says expectation of any function you want to find, that function into PDF. So that function into PDF. What is a PDF? 1 by x, 1 by 18, sorry, 1 by 18 dx, and the range of x is between 0 and 18. So we will integrate over 0 to 18. Now can you simplify this? So log 1 plus x, and that will reduce to log 19 upon 18, right? Now find the decimal form of this. Check the calculation. Okay, so log 1 plus x, log 19 minus log 1. Log 1 is 0 upon this. So ln 19 you calculate using calculator. Calculator is allowed in the GATE exam and JAM exam. So in the screen they will provide. So what is the value of log 19 upon 18? Exact decimal form. Yeah, so
It's 0.1635.
okay, 0.16 approx, right? Okay, so let's confirm. Okay, so yeah, 1635, correct. Now see, so it is saying, so these two are already out. So C and D are already out. Now you have this A and B. So this value you exactly got 0.16 approx. So 0.16 is more than 0.1. Yes. 0.16 is less than 0.1. No. So this is out. This is correct. So now those who were asking, what if it is not convex? Then this way. So there is always way. One question can be solved in 1,000 different ways. The thing is, we should know at least one way to solve. That is enough to qualify exam. Now, one question can be solved in 1,000 different ways. Yeah. So that is fine. So this is another way what you were looking. So this is the one way. So A is correct. And in that way also A was correct, right? Yeah, A was only correct in that way. So using Markov and Jensen's inequality, we solved that. Without using Markov and Jensen's, we solved this. Still the same answer. Okay. So let's come to this. I think this I imported already, or no. So there is a new term here, CDF, cumulative distribution function. So till now we have defined PMF, PDF, expectation, MGF. Now the new word is there, distribution function or cumulative distribution function. So this is the distribution function that we also called cumulative distribution function, or in short we say CDF. In PDF and CDF, D stands for different, I mean both are different D. In PDF it is probability density function. In CDF it is cumulative distribution function. So in D, in both PDF and CDF are different. Okay, so not the both are same. One is density, other is distribution. So CDF has cumulative distribution function. This is the distribution function. So I will first define what is definition of distribution function, then we'll continue. So what is definition of distribution function? So somewhere people defined distribution function separately, and then they define CDF separately, and then they say both are same. Okay, so let me first define distribution function. So distribution function of what? X or what? X be a random variable having distribution function. Okay, fine. So distribution function of X, or in short we can write CDF of X, cumulative distribution function of X. What is definition? So definition is, again it is a function. Like you have seen, PMF is a function, PDF is a function, MGF is a function, expectation is a function, probability is itself a function, random variable is also a function. So function from mathematics is very important here. So everything is defined in terms of functions. So this is also a function actually. So so a function fx of x this is CDF of X if and only if you can write probability X less than equal to X for all X belongs to R. Or if I elaborate, so this is a function from R to 0, 1. So this f is a function, this fx is a function whose domain is R and range is 0 to 1. Because this is probability now, so it cannot exceed 1. So CDF is a function whose domain is real number and range is 0 to 1, and this we define this way. Is it fine? Yeah. What is the difference between cumulative distribution function and a distribution? Okay. So that's why I said in few books, like I was giving interview to IIT Kanpur, and there I think Amit Mitra sir was there, and in the panel, and they asked me what is difference between cumulative distribution function and just distribution function or distribution. So the thing is, let me define it. So now, so this is what I defined as a CDF. Okay. If I write the distribution function, so let's say I define distribution function separately. Okay. What I believe they also wanted to ask me the same thing. So if I write this as a CDF of X, okay, which is called CDF of X. So this is definition of CDF. Now I defined distribution function. Okay, 1 minute, I think. So let me define distribution function. So the way I'm defining distribution function, so this distribution function has nothing to do with statistics or probability. So I'm defining distribution function in mathematical way. So it has nothing to do with statistics portion. Okay. So like a function f, but in the definition nothing to do with, but later we'll realize ki both are implies if and only if. So definition will not involve anything probabilistic term or a statistics term. So a function f which is R to R, I'm writing R to R. Okay. A function f from R to R is a distribution function or a distribution just if and only if, so that everyone know the conditions actually. So what they want, the value of f at plus infinity should be 1, the value at f minus infinity should be 0. So it doesn't mean exactly equal, it means tends to. So fx when x tends to minus infinity, fx when x tends to plus infinity. So we mean here tends to, not exactly. So f plus infinity means limit of capital Fx when x tends to plus infinity. So this, and the third is, so that everyone know. Okay. And the third is f is right continuous on R. So right continuous at every point in real number or every real number. Okay. So right continuous for all real number. And the fourth condition you all know, and this is f is non-decreasing. So f is non-decreasing function on R. Okay. So the way I defined, we have used nothing, no terms from statistics or probability. Is it? Distribution function just like a function, like step function, piecewise constant function or something, trigonometric function like this. So I'm defining distribution function. Now the result says ki every CDF will have these conditions, or any function that satisfy these 4 conditions will be a CDF. So you choose any function from mathematics or any function from anywhere that satisfy these 4 conditions will be CDF of some random variable x. Okay, so theorem says, so they are if and only if. So the theorem says every distribution function is CDF of some random variable x and vice versa. Converse is also true. Okay. So means you got this. Every CDF will satisfy all 4 conditions, or any function that satisfy all these 4 conditions are CDF. So maybe they wanted to ask me this. So somewhere I have seen this, I think that's why. So okay, otherwise we write this as a theorem ki f is a CDF if and only if this satisfy the 4 conditions. Okay, I think so this is enough, na? So now let's this will not be used here. I think this will be used. Maybe see what is there. Okay. So x be a random variable having distribution function this. Okay. And where a and c are appropriate constant. N is a set this, and a is union of ai's. Probability x less than equal to 1 is half. Ex is 5/3. Then what is probability of this? Okay. So CDF has common notation for the and common representation for the discrete as well as continuous. So there is no different representation. Like I said, ki discrete has PMF, continuous had PDF. CDF is a common term for all random variables. So even if it is not continuous or not discrete, neither of them, still you can write as a CDF. So now x is a random variable having this distribution function. So this term suggests it is the stepwise constant function, right? Or this is a piecewise constant function. So again there is a theorem ki if a CDF is a piecewise constant function, means it is the CDF of a discrete random variable. Okay. So what I want to say, like I defined CDF, I defined distribution function. They said both are same. If this, then this. And the next theorem, what I want to say is CDF of discrete random variable is stepwise, yeah, piecewise. A step function, no? I think this is called step function or piecewise constant function. So let me write piecewise constant function. That is all called also called a step function, I think. So discrete and this is piecewise constant function. स्पेलिंग देख लेना PIEC होता है PEIC स्पेलिंग देख लेना ठीक है ना आई एम नॉट श्योर अबाउट स्पेलिंग सो पीसवाइज कांस्टेंट फंक्शन and vice versa vice versa means if you have a CDF if you have a function distribution function that is piecewise constant, so that will be for the discrete only. What I said, CDF of a discrete random variable is piecewise constant function. Any distribution function which is piecewise constant will be CDF of discrete random variable. So vice versa is also correct here. And what if this is a discrete version of the theorem? What is the continuous version? So if I write similar thing for the continuous, so CDF of a continuous random variable is continuous function on R. Continuous function on R. And vice versa. Means if you have a CDF that is continuous over R, so that CDF has to be CDF of a continuous random variable, not for the discrete. So means if you have a CDF of a discrete random variable, there must exist a point where this will be discontinuous. So continuity is the characteristic property of continuous random variable. Continuity of CDF. Continuity of CDF is a characteristic property of continuous random variable. So if random variable is continuous, if and only if the CDF will be a continuous function on R. So continuous function on R. Okay. So let's apply this. So this theorem will suggest us that the given CDF is the CDF of discrete random variable. Okay. So given CDF is a CDF of discrete random variable. Okay, let's complete this question, then we'll stop after this question. So you can simply see if I make the graph, this is something like less than 1 it is 0, less than 1 it is 0, 1 to 2 it is a by 2, 2 to 3 it is c by 6, and more than 3 it is 1, right? So here is a number 1, it is a c by 6 and it is a by 2. Okay, so this is a graph of this CDF roughly, and where they include here is a open, here is a close, here is close, it is open, no. Okay, so you can see the graph of this function is a piecewise constant function, and that's why it is a discrete random variable. So this suggests x is a discrete random variable. X is a discrete random variable. Okay. By looking at the CDF, we got that X is a discrete random variable. Now, so discrete hai, how to find A and C? So we have given two conditions. This will help us to find value of A and C. So these two conditions are given to find value of the small a and small c. So find it. So, jump in the CDF represents probability at that point, or the point of discontinuity in the CDF is the point at which probability will be non-zero. So what is the probability? So what is the point of discontinuity? It is 1, it is 2, it is 3, and so on. So there are 3 points of discontinuity, 1, 2, 3. So the probability at 1 will be length of jump. So length of jump is the probability at that point. So what is length of jump? So length of this jump is a by 2 minus 0. This jump is a by 2. So probability at 1 is a by 2. Probability at 2. So length of jump. So length of jump at 2. C by 6 minus a by 2. So C by 6 minus a by 2. And the jump at 3. So length of jump is 1 minus C by 6. So 1 minus C by 6. Okay. Now, so this you got the PMF actually, but still C and A are unknown. This is the PMF of random variable X. This is the PMF. Okay. 0 otherwise there is no jump. So this represents probability mass function. You may write as a table like I was writing x1, x2, x3, p1, p2, p3. So x1, x2, x3, p1, p2, p3. So you have this. Now you just find probability x less than equal to 1 is half. Okay. So probability x less than equal to 1. So what is the range of random variable x? X can only attain value 1, 2, 3. So they are saying probability of x less than equal to 1. So there is no value less than 1. So means it is 1 only, and means it is a half, and that we already have a by 2. That we have a by 2. So this implied a is 1. So we got a as 1. See? Okay. So a we got is 1. Ex is 5 by 3. So use this PMF to find Ex, or you may use CDF. So okay, let's use this. If you find Ex, so it is a xi pi. So it will be a by 2, 2 into c by 6 minus a by 2, 3 into 1 minus c by 6, and it is given as it is 5 by 3. The expectation is 5 by 3. It is 5 by 3. Now what you will do? You already have value of a. Put the value of a. You will find the value of c. What is value of c? Tell me.
So C is equal to 5.
5. Fine. So others, please verify it whether you are also getting 5. So now we have value of a and c. Okay. So now we have PMF. See here carefully. So an is defined here as, or given here as 1 plus 1 by n, 3 minus 1 by n. Okay. And they are talking about capital A is union of ai, I from 1 to infinity. So what is that A? Can anyone suggest? So 1 plus 1 by n will be somewhere right side of 1. This will be somewhere this. Okay. So if you increase, okay. So there is again theorem, continuity theorem of probability. You can use that, and that will tell us that. So see carefully. If you write a1, so this will be 1 plus 1, 2, and 3 minus 1. N is start from 1. Okay. So I think it is singleton 2. Okay. Okay. A2. What is A2? So A2 will be 1 plus 1 by 2, 3 by 2, and 3 minus 1 by 2, 3 minus 5 by 2. So one thing you can notice here is, what do you notice? If I proceed further, you will notice A1 is subset of A2 is subset of A3 and subset of so on. So AN is an increasing sequence of sets or intervals. So this AN is increasing sequence of intervals. So now you can easily tell me what is the okay, limit n tends to infinity. This is going to be probability union of I from 1 to infinity. Okay, let me just write union of AIs, not probability. Remove the probability term. Later I will use the probability term. Without probability I'm writing. So union of I from 1 to infinity is going to be an limit n tends to infinity. Why? Oh, union is there, no? Yeah. So since it is increasing sequence, so last one is going to be union of all. A subset of B. A union B is B. So if you take the union, the last one is going to be the, so what is the last one? Limiting sets, limiting interval. Can anyone tell me what is the limiting interval? What is the limiting interval? 1 and 3 will
Open
be fine.
interval 1, 3.
Open or close?
Open, sir.
Both side open. Yes.
Yes, sir.
You can see carefully, hai na? Because it is right hand limit of 1, it is left hand limit of 3. That's why. Okay. So right hand limit of 1, left hand limit of 3. So 1 by n will never become 0. Because 1 by n will approach to 0, but it will never be 0 actually. So this interval is going to be 1, 3. Now you got what they asked. So this is your A that was given here. That is your A. So A is this interval that they asked. Now can you tell me what is probability of x belongs to A? So see, x had only 3 value, 1, 2, 3. So you just need to see which value will fall into this interval. Only 2. So only 2. And what is the probability at 2? Here it is given. C by 6 minus A by 2. So C by 6 minus A by 2. What is C? 5. What is A? 1. So 5 by 6 minus 1 by 2. So 1 by 2 is like 3 by 6. So it is 2 by 6. I think 1 by 3. Check. So 1 by 3 is the answer actually for this question. So I will stop here only. You know? So yeah. So any question?
Sir,
Yeah, tell.
can you please explain why we write here open interval 1, 3?
Yes, because you see carefully. The an we have is interval 1 minus 1 plus 1 by n to 3 minus 1 by n. So the question is 1 plus 1 by n will approach to what?
As limit n tends to infinity, it will
Yes.
approach to 1. It will
1.
give us 1.
So it
Okay.
will this term ever attain value 1?
No, sir, it is limiting value.
Yeah. So that's why it can never attain value 1. So you cannot tell 1 actually. You cannot write 1 and 3 here. Why? Because 3 is never included here. 1 is never included here.
Thank you, sir.
Yeah. So it is something like 1 plus epsilon, 3 minus epsilon. Like this. 1 plus epsilon and 3 minus epsilon for all epsilon more than 0. That ultimately will be 1, 3 open interval. Okay. Yeah. So I think that's all for today. Thank you, everyone. Yeah.
Okay, thank you, Santosh, for this nice session with all the details of the problems. Okay, dear participants, now feel free to share your feedback about the session. Yeah.
Sir,
Yes, Ramesh Kumar.
the way, yes, sir. The way of he taking is absolutely nice, sir.
Okay.
And also with whiteboard he's teaching is easy to make to understand,
Mhm.
and also is explaining basics, definitions, and theorems. So it's very, very useful, sir.
Yeah, thank you.
Thank you, sir.
Yeah, thank you, Ramesh. Could you introduce Ramesh yourself?
Sir,
Uh,
I completed MSc, sir,
okay.
preparing for NET exam, sir.
Okay, you are from?
Okay. From Coimbatore, sir, Tamil Nadu.
Okay, Ramesh. Thank you.
Thank you, sir.
Yeah, other participants, feel free to share your feedback about the session.
Sir,
Yes.
the way of teaching is very good, and sir is just completing syllabus in a single paper. A whole syllabus is getting completed. Thank you, sir, for completing every concept.
Yeah, thank you.
Okay, thank you. Muhammad Owais, could you introduce yourself?
Yes, sir. I am Mohammad Wais from Jammu Kashmir, sir, and we are having no resources here to
Okay.
watch statistics. And thanks to Santosh, sir.
Okay.
Yeah,
Okay, thank you, Muhammad. Okay, others?
Sir,
Yeah.
while explaining third sum, you told there was three types of random variable like discrete, continuous, and something which is neither. I know it's time to wind up, but either in the upcoming session or in the WhatsApp group, kindly explain what is that neither category?
Okay, I
What
think you
kind
are
of
asking category of random variables.
category of random variable which is neither discrete nor
Yeah.
continuous?
Actually, there are three category. If you say very strict sense, there are three type of random variable: continuous, discrete, and neither, which is called mixed.
Mm.
So what is a mixed random variable? So CDF of mixed random variable can be written as this.
Okay.
So this is the CDF of mixed random variable,
Mm.
or we say X is a mixed random variable. So this is a mixed random variable that I call mixed random variable. Book don't write mixed random variable. So
Mm. Mm.
mixed because it has both PMF and PDF part. It will not have only PDF, only PMF. In fact, this X will not have PDF. This will not have
Okay.
PMF. It will have partial PMF, partial PDF. Total, it will be one. That will be the case.
Okay.
And FD is here is the lambda is between 0 and 1. So this
Mm.
is the CDF of discrete random. D means a discrete. So yeah,
Mm.
instead of X, I may write M. So CDF of mixed random variable, we may write. And
Mm. Mm.
so CDF of discrete. And this is the CDF of continuous. Okay, let me give you one example. So the example is this one. 0 when x less than 0. Half plus x by 2 when x between 0 and 1. 1 when x
Mm.
more than equal to 1. So in the continuous, derivative of CDF is PDF. But if I make
Mm.
the graph, let's make the graph. So graph is 0, and then
Mm.
this one start with half, and then this one.
Okay.
So there is a point of discontinuity at point 0, right?
Mm.
So
Yes,
this
sir.
cannot be continuous, because I said X is continuous if and only if CDF must be continuous function on R.
Yeah.
So this
Yes.
cannot be continuous. Then I also said
Okay.
X is a discrete random variable if and only if CDF is a piecewise constant function.
Mm.
So is it
Mm.
piecewise constant function? No.
Mm.
So that's why this CDF is neither discrete nor continuous. Or I can say this X
Wow.
is neither discrete nor continuous.
Okay. Nice. Thank you, sir.
Neither discrete nor continuous. So there is a third category of random variable: discrete, continuous, and neither. So X is neither discrete nor continuous. This random variable is neither discrete nor continuous. Yeah. Thank you.
Okay, sir. Thank you so much. That was an interesting example.
Yeah.
Thank you.
Okay, Revati, could you introduce yourself?
Sir, I have done MSc B.Ed and I'm preparing for NET exams, sir.
Okay, you are from?
I'm staying around Chennai, Tamil Nadu.
Okay. Thank you, Revati.
Thank you, sir.
Yeah. Yes, Praveen.
Yes, sir. Uh, Good evening, sir. My name is Praveen Casey. I'm from St. Thomas College, Thrissur. I am currently doing my sixth semester in UG BSc Mathematics. So, as you said, I am from Max background. So it was very nice of you to have explained each and every definition and theorem and all. You explained even how to take the constant out of that expectations. So that was really very interesting, and the class was very easy for me to follow. So thank you for the great session, and looking forward for more classes from you. Thank you.
Yeah, thank you.
Hello, sir.
Good evening, sir. Good evening, sir. I am Dharmendra Singh from Karsan, UP. I am preparing for also IIT JAM Mathematics also. I want to ask about some books of basic probability and statistics. And I want to ask what is importance of statistics and probability in mathematics and physics also.
So for the book, you have actually, for the basic, if you want to start with zero, there is a book called Introduction to First Course in Probability. You may go through First Course in Probability. Book name is A First Course in Probability by SM Ross, Sheldon M. Ross. This you can go through. For the advanced level, you can go through Introduction to Probability in Statistics, introduction. So like the one who wanted to know this, these things are already explained in this book. The second one I'm writing, so this part that I was explaining, the mixed thing, this is given in this book. So you can see Introduction to Probability in Statistic, Introduction to Probability in Statistic by VK Rohatgi, Vijay Kumar Rohtagi, and AKMD Salah. So this is advanced level book. This is not the basic. Although name says introduction, but this is not the introduction actually. So initially people may not understand this. So initial people may, or one or more Indian author book you can follow is the Probability in Statistic by Prasanna Sahu. Google, you can Google it. All PDFs are available online. You just Google it, PDF you will get. So these are the book you can follow. And what is used actually, in the research level, there is no boundaries. You may do interdisciplinary research. Nowadays data science, AI, machine learning, the backbone is statistics actually. Statistics with programming. So a data scientist must know statistics. Without statistics you cannot be data scientist, data analyst, or something. So that is very useful. In physics also people use, but I think I may not be the right person to tell you how to use this in physics. But I have seen many things. Like I work in entropy and extropy estimation. So entropy word came from physics only, and that now I use in statistics. So entropy is a measure of uncertainty in a system, and that entropy is the same thing that used in thermodynamics. So from that it came in statistics. So now I work in entropy and extropy. Both are a measure of uncertainty, and in estimation I work. So they are interrelated actually. Many physical applications we write in research paper, that we explain how system work and all that. So they are related actually. So for that you have to read some research paper, I think. Okay, thank you.
Yes, sir.
Yeah.
Thank you, sir. Thank you so much.
Okay, thank you, Dharmendra. Yeah, Elizabeth, you started to say something.
Yes, can you hear me, sir?
Yes.
Okay. So my name is Elizabeth, and I'm from Kerala. And I just completed my MSc and now preparing for actually for ISS. And also I'm following your classes on YouTube, and that is really helpful for students like us from statistics actually. And all your doubt clearing sessions are also very helpful for us. So, sir, have you ever appeared for ISS or RBI exam?
No,
Any
actually, I had no
suggestion
interest
about
in.
that exam?
I had no interest in MNC or in ISS, RBI. I want to be in academic. I like teaching, so actually, I never appeared in ISS or RBI or for the placement for the MNCs. Even though I did MSc Statistics from IIT Bombay, so except me and Ankita, two students from my batch, all of them joined MNC and we joined PhD. So only two people out of batch of 32 people in Bombay. So I had no interest in joining government services like ISI or RBI, and neither in MNC. So I wanted to be in academic, so I came in academic actually. Thank
Okay,
you.
sir. So thank you, sir, for your all your efforts.
Yeah, thank you.
Yeah, Ivana, yes.
Sir, it was a wonderful section and you explained everything from the base. So as a beginner, it was very easy for me to follow. Thank you, sir.
Yeah, thank you.
Yeah, thank you, Ivana.
Sir,
Yes.
sorry to interrupt you, and I have a doubt and a problem, but I don't know how to share that problem here because I couldn't share my screen from my mobile.
I think you can share on my WhatsApp. I will send you solutions. So actually, my team member has
Okay,
bus
sir.
at 10 p.m. So I have to go him to drop at bus stand. So he has to go at
Okay.
10. Yeah. So
Sir,
you
the
share me on
joint
WhatsApp.
PDF.
On this
No,
number you
yes,
can
sir.
share. I think you may share on my team numbers. You may. And there is a YouTube channel that you can also see. So you can share on this number. And then I will send you written solution there. Okay. You send there. Yeah.
Okay, sir. Thank you.
Yeah. Thank you.
Is it 9392 at last?
Repeat, please.
Is that 9392 the last 4 digits of your number?
Yeah.
9392. Yeah. 9392. 8810409392. Yeah.
Okay, sir. Thank you.
Okay, thank you, Revati. So, thank you, Santosh,
Yeah.
for
Thank you,
this
sir.
nice session. And I enjoyed your session really. So, I hope that you will be there to help our initiative in future too.
Yeah, sure, sir. Sure. We can have monthly session. You can fix a date, no problem. Or weekly also, I don't mind. I like teaching actually. So, yeah.
Okay. Okay. Thank you. Thank you,
Yeah.
Santosh.
Thank you, sir. Thank you. Yeah, I have to
Yeah.
go to.
Thank
Yeah.
you, everyone. Let us wind up here. Thank you.
Thank you, sir.
Bye.
Bye.
Thank you, sir.